So today we've got an objective to write ratios and solve proportions. Again, to write ratios, solve proportions, properties of proportions. Okay, so we're looking at 7.1 day 2. This is on page 3 of your note packet, I believe. So we're looking at proportions, an equation that states that two ratios are equal. Extremes, the first and last number in a proportion means the middle numbers. And what's that mean is this. When we set up a proportion with the semicolons, or the colons, excuse me, not semicolons, but colons, we are looking at the means are the inside values next to the equal sign. The extremes are the outside ones. So that's how we name these, means extremes property. Okay, now in a proportion, the product of the extremes equals the product of the means. I want you to keep in mind that you could solve a proportion that way, and it totally works. But most proportions aren't easy to solve just looking at it. But what do I multiply 3 by to get to 12? No way. I could use equivalent fractions. So times 4. Are you okay with that? It's an equivalent fraction. I'm using a form of 1. Okay? Really, when we set up these proportions, I can use all the skills of fractions to help me solve them. The reason we learn about the cross product is because they can get souped up. They can have not really nice numbers to solve for. So we have a method to solve when it's not. And that's what's coming up here. We have a method to solve for. So that's what we're going to be working on. And that's that cross product. Okay, and that's what they mean. It's the product of the means is equal to products of the extremes. Okay, so now when we're looking at this, I got 4 times 6 and x times 5. So I'm here. 5x equals 24. Are you okay with how I got 5x and 24? Okay, I just divide by 5. So now I got 24 fifths. And I have a lot of people going, boom, isn't that 4 and 4 fifths? Or isn't that 4.8? Context is important because we're talking about a ratio. In ratios we are working with, we should have reduced fractions. And since it's a ratio, I should have one number to another. And 24 fifths is more descriptive of a ratio than 4 and 4 fifths would be. Because all of a sudden I can see in my mind 24 things to 5 things, okay? And I can see how that would be set up. If I'm talking about slope, 24 rise over a 5 run, boy, that's really descriptive versus the mixed number. So I would want you to make sure that when you're answering a question, keep in mind the context in which you're answering it. Okay, in this case, we're working with ratios. We should have it as a fraction or separated, but with a colon when we're doing our answer. So if you would, please solve B. Hopefully, you're at A is 63. Are there any questions about what we're doing? Now, when we do this proportion stuff, most of the time the instructor will review all the skills and stuff you need to get there. Right now, proportions the skills we're reviewing. And I'm assuming distributive property that's coming up in C is something that we got down. Okay, so I've got 3 times the quantity y plus 4. So I got binomial and monomial on the left side, and I've got 9 times y. I got to distribute, so I got 3y plus 12 as I look at my relationships to solve. And now I'm going to subtract by 3y and find 12 is equal to 6y, and y is 2. My concern when I'm doing this is which number is doing the division. Okay, and I want you to be thinking about which number is doing the division, because that's the one that should be on the bottom, okay, in my solving. Any questions about where 2 came from or how it came about? All right, your turn. Do D, please. like a Funyun trap for the instructor. Ooh, boy, that looks good. Get caught in a leg tear or something, or somebody's laying there hung up by a tree. Okay, 15 times m, and m plus 1 times 3. So I'm here, but did you get to a fourth versus 4? Be careful about what you're dividing. I know 12 and 3, they have a factor of 4 in common. I mean, 3 times 4 is 12. But when I'm dividing by 12, it becomes a fourth. Okay, I'm not dividing by 3. Okay, so be careful about what's doing the dividing when you set these up. Because sometimes you're thinking so fast and you're worried about getting to the next one, you fail to remember which one should be in the denominator. Okay, so sliding on. We're looking at properties today. And I probably should have one more property, extremes exchange property, and I'll talk about it when I talk about the means. I'm going to let you guys get these down real quick, and then we'll talk about these. Okay, so here's the deal. I'm looking at the reciprocal property. And a lot of times students are like, oh, I'm going to remember this. It's all about your problem solving when you're working with it. So look at what I've got. We're going to always, in a situation like this, I will give you the setup of the property. Okay, this is a proportion. And it is equivalent to this next thing. But I only give you the first half of the proportion. I want you to predict, using your thought process, what the other half of it would be. Okay, if I look back, I go, oh, well, I had A over B, and now I got B over A. They just flipped it. Well, the other side should therefore be flipped. And we're here. Does that make sense? Okay, I get a lot of folks that get to the point that, oh, geez, this is something math-wise, and I don't really need to know. You need to know the name. It's reciprocal property. But just because you need to know a name and you can't remember it doesn't mean you can't help yourself out of a hole to figure out what the property is. Okay? And if I look at this, which is what happened. Okay? So that's reciprocal. It's just flips my fraction. Denominator becomes numerator. Numerator goes to denominator. Means exchange. Now, this is aptly named because originally the property is this, and I am just flip-flopping the inside values. The B and C are going to flip because I got A over C, and now it should be B over D as my filling out the property. Okay? Are you doing okay with this? Now, something that comes along with the means exchange property I don't have written down is the extreme exchange property. And I probably should talk about it because these are the extremes, okay? And if I can switch the means, I should be able to switch the extremes. So in this case, the extreme switch would be something like that. Okay, so an extreme switch would be, well, you know, you start out with D, you got D over B, and then you got to fill it out, and you realize it's C over A. And that's the extremes exchange. Okay, and you can get to there using the reciprocal and the means exchange, but I just wanted to be out there and tell you it's a property depending on the text that we work with. The text that you guys have online actually doesn't talk about the extremes exchange property, but it's a real property. The last one here is something called the adding one property. Now, I always get folks and they look at this and they go, what are you talking about? You're adding one, but you got a B in there? Where did that come from? So let's discuss the adding one property. And whatever I do to one side, I must do to the other. When I'm doing the adding one property, you got to keep in mind, I'm adding fractions, right? So that one's got to take on a fraction idea. Isn't B over B the same as 1? And why did I choose B is because it's the denominator. I had to have like denominators. So now I got A plus B over B. That's what that is. That's what happened. No way. That totally seems like it works. Well, then this other side, well, that's going to be D over D, and then that's C plus D over D, so that must be C plus D over D as my answer in the adding one property. Okay? And that's where that comes from. Now, the shortcut, instead of showing, well, you know, we added the fraction and went through there, notice that the denominator was added to the numerator. That's the adding one property. You could even look at it as a connection of the adding one property, subtracting the denominator from the numerator. Okay, so keep that in mind as we're going through. Now, what's all these property things got to do with things? When you apply a property, whether it's reciprocal, means exchange, adding one, or extremes exchange, what I showed today, if you do a cross product, those should be the same. This should be an equivalent statement. This should be the same relationship we are solving for. So what I want you to realize is that when I'm asking you, like in this sub question after 3, which is not an equivalent proportion, and I say think cross product, just do the cross product. Do the means exchange, extremes exchange product thing. Okay, and people are like, well, what do you mean by cross product? 6y is equal to 7x. Find the cross product of all 4 of them and determine which one of them is not the same. Okay, go ahead. So if I go through this, I got 6y equals 7x, I got 7y equals 6x, I got 6y equals 7x, and I got 3 6y's equals 7x's, and then I have one that ain't. And that happens to be C, right? So C is the one that is not equivalent, okay? And I was able to find equivalence by finding the cross product and determining, although they look different at the start, their cross products are the same and therefore they are equivalent properties. So a lot of times a student will go, Mr. Bloom, I did mine differently. I go, what's the cross product? Is it the same as mine? He goes, yep, then we did it the same. Okay, they're equivalent statements that we have. Okay, this look a little different. And this next one, I want you to apply a property. Okay, please look at in the diagram, x to 6 is equal to y to 7. What ratio completes the equivalent proportion x to y? And name the property you used. Go ahead. Now, keep in mind, we just went through 4 properties. The first thing is, what's different? The 6 is no longer down there. So, but the y is. So the 6 and y switched positions. They happen to be in the means positions. So I've got 6 over 7 here, and well, apparently I did fill that in. Okay, let's put that there. Are there any questions on how I did that and how I was able to name it? We're doing okay? Now, going to the next page. In problem 4, I had to do some renumbering. I fixed it on yours, I didn't fix it on mine, so I'm hoping that it's right. I would like you, based on the patterns that we've just learned in the properties, what ratio completes the equivalent proportion? I have ratios here that are in A, B, and C. I'm using the properties I just presented. I would like you to fill in the other half of them. And if you want to know what a test question looks like, bing, 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 I almost guarantee it's there. Like, not even almost, I guarantee it's there. Okay, I was just looking at it this morning. So be comfortable with this, be able to fill it out. Go. Based on the properties we just did. And please name the property that you're using. If you need to, look at your notes. That's what they're there for. They're there to help remind you. How you doing? Are you doing okay? Did those make sense? Now, re-look them over. Check out what was going on. You had the notes, okay? And you saw the reciprocal. Because it was x over 6 and went 6 over x. So that's, once it flips, you got to be thinking reciprocal. Once you see the denominator added to the numerator, you got to be thinking adding one property. Okay, those are the hints that tell you what's going to go on. Okay, once you see that 6 is on top and 7, is over on the side, that's kind of a crazy thing, and I don't think that's extreme exchange. I was thinking it was extremes exchange, and I was thinking that I did that, but I'm not sure why. I had it up there. It's reciprocal and extremes exchange and means exchange, not extremes exchange. Okay. For some reason, I thought I saw this 7 over 6. I apologize for that when I made that up. I was like, oh, good for me. I did that. Not good for me. Okay. So it was a reciprocal. It flipped the 6 up, and I exchanged the means, and that's how I got there. Those are the two properties I did, the combo property. Are you okay with how I got there? That one's a little tougher, but does it make sense as I think about the properties? Yes, sir. If I'm looking at the extremes, remember if I take this original property and I'm talking about x to 6, y to 7, the insides are the means. The outsides are the extremes. So in this case, if I let x and 7 switch, if I went and said this, that's the extremes exchange property. Does that make sense? And the only reason is, I mean, it's as straightforward as I just switched the extremes positions, okay? And that's why we named the property that way. And it's all about the name of their position. I got the reciprocal and I got adding 1. I mean, adding 1, I'm just adding 1. I mean, I kind of showed how the adding 1 came about, but we know that as a symptom of just adding the denominator now to the numerator, okay? So it seems like it was really a tough question, but as we work with the properties more, you start using them and use the names. You'll remember them pretty well, okay? Did I clarify that? Okay, awesome. Now, in this next part, I had this open. Explain why 6 over x minus 6 is equal to 7 over y minus 7, okay, is an equivalent proportion to x over 6 and y over 7. And I've got a lot of people that freeze. I remember we can do combo properties like we did in C here. What if I went x minus 6 over 6 and equal to y minus 7 over 7? Because I can do that. That's actually equal. And let me get that out of the way because it might get confusing. So what did I do there? Yeah. I did subtract, but what did I do from this one to get here? I just flipped them, so I've got a reciprocal property going on. So that's thing 1. I've got reciprocals helping me. And people are like, oh, how do you know that you had to do the reciprocal? I want the variable on top, okay? Now, could I use adding 1? Would adding 1 make sense here? Because remember, the adding 1 property really comes down to me just adding the denominator to the numerator. So if I take the 1 on the left, x minus 6, and add the denominator to it, x minus 6 plus 6 is just x. And do the same thing here. X minus 7 plus 7 is just, or excuse me, y minus 7 plus 7 is just y. So all I'm doing in this property is that. And I wanted to explain myself before I gave you the answer so you guys knew where that was coming from. Oh, nobody wants that cloned. Sorry, guys. So that's me explaining myself on that property. Now, after you write that down, I know it's a sad state of situation, but we're at a time for a self-quiz, trying to figure out what we get about what we presented over the last 2 days. So go ahead and do number 5 and number 6 and number 7, just to see where you're at. Number 5, number 6, and number 7. If you need a calculator, I have some on the back counter. And remember, I mean, I've got them to borrow, but it's always great to make sure that you have a calculator that you can use all the time so you're familiar with using it. So here's the deal. We're looking at these, and we're asked to the nearest millimeter. A cell phone is 84 millimeters long and 46 millimeters wide. What's the ratio of the width to length? Width has to be first because they told me it does. This width to length was secretive. That's why the width is first and the length is on the bottom. Maybe if the length's on the bottom. I have it here, but it's not there, so we will put that in. The length's on the bottom. I have to reduce that. And whether you put it in as a fraction or you put it in as a ratio that looked like that, I'm fine with. I don't care either way, but it has to be reduced. Now in 6, this one, the wheels on the bus kind of fall off a little bit because people go, we did this? Remember yesterday when I had those extended ratios and the problems? And I said, you know, do you remember when, you know, what the, did not remember, but know what the value is that they took out, they factored out before they gave us the final answer? And everybody's like, no. I was like, put in the unknown value of x, because that puts their relationship in terms of x. Notice that word, okay? It puts it in terms of x and allows us to understand that I can place that in and it'll still be the same ratio. So if we read the question, two angle measures, somebody has problems with his S's. Two angle measures should be angle measures. I've got to just change that. I'm having a hard time the reading today and putting my S where it's supposed to be. Okay, we're going to get rid of that. Two angle measures are in the ratio 5 to 9. Write expressions for the two angle measures in terms of the variable x. I just want you to go 5x to 9x. In terms of the measure x. I've just introduced that into the problem. Now, a lot of times the difficulty isn't about the math, it's about what's being asked and understanding that. So please reread that question right now. And after you're done, go ahead and answer 7 if you haven't had time already. So in problem 7, you should be getting that solve on. Go ahead and solve 7. And after you're done solving 7, answer 8 exactly the way we did in number 4. And you got to be wondering, geez, this is like the 3rd time he's done this. Must be an important question. Must be already on the test. So when I'm solving 7, I got 3 times 20, which is 60, and I got 5z. I take 60, divide by 5, I get 12. So 12 is z. And what I want you to do for your answer to check it, and I'll present, I want you to make sure that you fill in the missing pieces of the proportion, but also give me the name of the property you're using. Okay? Fill in the pieces and provide the name of the property you're using. So go ahead and do that in 8A, B, and C. After you're done, I want you to share with a person next to you. And I will assign those. This group, you guys will just go straight across this way. And if you wouldn't mind this, go ahead and talk to those two. Okay, thanks. You guys, role partners, you all will role partner. That's why if you go forward with there, and I know it's long distance relationship between you two. Okay, so if you need to or want to, you guys can move. After we do this, we're going to compare our answers from last night's assignment. So might want to just move closer to each other. Okay. Now, go ahead and talk to those folks that we've got and share your understanding with it. And remember, part of this is us learning how to respectfully discuss differences. Okay, and it's pretty safe because it's numbers, but we should be able to respectfully discuss it without being loud or obnoxious. And remember, the loudest isn't the most right, they're just most annoying. Okay. Just 1 through 11 yesterday. Yep. And then after you're done, go ahead and start finishing the backside. You're comparing answers on first on this, and then on the homework. Okay. And then I will interrupt after we're done. But you're doing it on this first, and then the homework. Yes, sir. How is that possible? I can't count. Oh, let me get a sheet for her. Do you need one too, Johnny? Do you need something too? Okay. Here you go, dear. What do you got, sir? Nice reach.
For 18, I don't know how to find the line. Oh, wait, never mind. I see.
This is the perpendicular bisector of this. That means this is isosceles.
Okay.
With that being a vertex angle.
Okay.
Okay, I think with that information, that's helpful. Okay. Yes, sir.
Is this due today?
Yeah, we're correcting it right now. I mean, you guys have just talked about it. I'm going to answer any questions. I'm going to have you guys hang on to it until Friday, but it should have been done today so we can discuss it. Okay. Otherwise, 1 through 11, and we're going to do the back side right after we correct the front side. Yeah, so no problem on that. Okay. Okay, so let's back up what's going on. You guys are doing some great discussions. I have a lot of people asking questions, and I want to clarify a few things. First, we're going to answer this question. I'll do this last thing with you. And then we're going to finish with the questions because you had time to compare your 1 through 11s right now, and now between you and your partner, you have questions, and we're going to discuss those questions. After we do that, we're going to flip it over, and we're going to spend about 5 more minutes, and we're going to finish the backside of that assignment. Now, keep in mind, I'm going to have you keep that assignment till Friday. And people are like, why is he letting us keep it till Friday? We were supposed to have it done today. We had it done so we could be part of the discussion. Okay? Otherwise, you'd have been like not adding to it and letting your group people down, not getting it done. The other part of it is that I want you to realize that I'm going to quiz on this material. I don't want you to be kind of half understanding it. I want you to kind of have an opportunity to read over and check out your answers and make sure you get it before you hand it in, as opposed to, oh yeah, I just got it done. You know, I'm just marking that off. Because it's going to be quizzed next week, I promise. And you don't want to be half understanding at the time of a quiz. Okay, so that's my purpose in my head of what we're going to do today. But let's look at this first. You had an opportunity to talk about these, and hopefully this is what you've got. How you doing? You okay with the applying the properties? Okay. Now the last thing, the difference between proportion and ratio. Some people have filled that in, but in a nutshell, a ratio is a single comparison. A proportion is a statement that states 2 ratios are equal. Okay. It's connection between 2 ratios. Let's see if we can get that a little higher somehow. It is not letting me get it much higher, so I apologize for that. So that's the end of notes. Okay, so if you're at home, you're not benefiting from the knowledge of your row partners by learning about what they get and what you get on your assignment. But just make sure we're finishing the 7A assignment and we start the 7B assignment, and you can print that off from Schoology in the same place that you received this video. Okay, have a great day.